All right, so what I'm doing here is I'm doing PowerPoint for the answers for the homework assignment that I just, not homework assignment, but the worksheet I sent out to you after the pancake test dealing with chemistry and not pancakes or cupcakes. So what we're going to do is apply basically the same ideas as we did for recipes and make to make things like cookies, whatever, pancakes, cupcakes, or whatever. We can apply it to chemistry because they're you use the same ideas. Okay, so let's. All right, the first problem set. There were just a couple problems here, and this is going to relate to similarities between cups and recipes, but instead of using cups, we use moles per recipe. And the chemical equation is that there's one pentane for 8 oxygens, for 5 carbon dioxides, and 6 waters. And you got these numbers by balancing the equation. Okay, so you set up the table, recipes, moles per recipe, and moles, just like you did recipes, cups per recipes, and cups. And the question, and then put in what you know, put in the moles per recipe, which are the coefficients. Okay. So you do that for every single problem you have, all right? You'll write out the balanced chemical formula, start the table out. We're going to expand the table in a few minutes. But when you just have moles, make sure you put the moles per recipe in the coefficients where the moles are, moles per recipes. All right, and it says you want do the recipe 10 times, okay? What this tells us, our table tells us that for every reaction, we need 8 oxygens, and we're going to do that 10 times, so we're going to need 80 moles of oxygen. Okay, so that's number 1. Number 2, we're going to go the other way. So we're going to start out with 8 moles. We know every recipe needs 1 mole per recipe of pentane. So if you need 1 per mole per recipe and you have 8 of them, you can see that you can do the reaction 8 times. Okay, so divide the 8 by 1. So again, like in the previous, going up, you divide, going down, you multiply. Okay, right. You're always going to go to recipes, no matter what, and then you're going to go, unless you're given recipes like in the first problems, but you're always going to need to find out number of recipes to figure everything else out. Okay, next problem. How many moles of carbon dioxide will be formed when 24 moles of oxygen are used? So set the table up. Here's your balanced equation. Here's your table. Put in the moles per recipes. You start out with 24 moles. Every recipe needs 8, so you can divide the 24 up into groups of 8 to get 3 recipes. Okay, bring the 3 over here. So if you can do the recipe 3 times, every time you need it, do it, you get 5 carbon dioxides. So you can do 5 carbon dioxides 3 times for 15. Okay, next problem. How many moles of water are formed when 4 moles of pentane are combusted? Okay, so set up your table and put 4 moles of pentane here. You want to find out how many recipes that is, so 4 moles can give you 4 recipes. Okay. So go back here to this. Okay. All right. So you can do the recipe 4 times with 4 moles of pentane. So bring the 4 over here. And every time you do the reaction, you get 6 waters. So 6 waters 4 times is 24. Okay, now to do problem set number 2, we have to add another thing. We have to add the molar mass. To do these problems, and these encompass everything about the full range of these types of problems. you need two things to do these types of problems. You need the balance equation, because the coefficients give you the moles per recipe, and you're also going to have to know the molar mass. Okay, and that will go into grams per mole rule. It's called the molar mass, and molar mass is grams per mole. So if you go back and listen to the intro to the mole, at the end of that, I talk about how you can figure out the molar mass of molecules and atoms, and we'll go over that now as a review, a little tiny review, so you can know how to apply. Okay, to find a molar mass, you need the periodic table. Okay, and what you need to know is you need to know the number that is just under the chemical name. All right, like beryllium, you'll see this number 9.0122. And what this number is, okay, and I went over it in the intro to mole video, was that this gives me the mass of the atom, either in terms of AMUs or grams per AMUs per atom or grams per mole. So, but what we do is we round it to the nearest whole number. So beryllium's mass would be 9, okay, not 9.0122. And right now we'll say that beryllium weighs 9 grams per mole, right? And so if you look at, let's look at boron. Boron, what you do is round to the nearest whole number. So it's 10.8, so we'll round to 11. So boron's mass is 11 grams. Okay, so for the problems that we're doing, we're just going to be dealing with, they'll have carbons in them, oxygens, and hydrogens. So carbon's mass is 12.009, rounded to the whole number, that's 12. Okay. Oxygen 15.999, so round that to 16. And hydrogen, we'll round to 1. So carbon's mass is 12, oxygen's mass is 16 grams, and hydrogen's mass is 1 gram per mole. Now to figure out the molar mass of a molecule, okay, what you do is you use the sum of all the atoms in that molecule. So pentane, which you're going to be using in these problems, has 5 carbons, okay, each one weighs 12, so it's going to be 12 5 times, and then you're going to have each carbon weighs 1, and you have 12 of them, so that's 12 times 1, and then 5 times 12 is 60, and 12 times 1 is 12, add them together, and you get the molar mass of pentane is 72 grams per mole. For oxygen, each oxygen weighs 16, and you have 2 of them, so it's going to be 2 times 16, or 32 grams per mole. Carbon dioxide, 1 carbon, 2 oxygen, so 1 times 12 is 12, so the carbon is 1 times 12, and oxygen is 2 oxygen, 2 times 16 is 32. 12 plus 32 is 44. And the molar mass for water, there's 2 hydrogens, so 2 times 1. Okay, and then there's 1 oxygen, 1 times 16, so the molar mass of water is 18 grams. Okay, so now what we're going to do is apply this. All right, and we get this. So this is our starting table for this. For any problem that has to do with the combustion of pentane will look like this. Okay, so the coefficient will go in. Okay, we'll go in the moles per recipe, and then the molar masses will go in this row here. Okay, so there's 2 things you need to do these problems. You need the balanced equation for the coefficients and the molar masses. Okay, now when you do molar masses, don't do this. Don't multiply 8 times 32 to come up with the number. This 32 is only how much one of these O2s weighs. Okay. This 72 is how much one of these, just one of these weighs. Okay. So this number here, the coefficient goes here. So don't put it, don't multiply this number by it as well, because then you're basically doubling its effect. All right. So this is your start table for the problem set number 2. All right, the first problem. The first problem says we have 5 moles of pentane, so put the 5 here. And I ask you how many recipes you can make, and how many moles of water, on how many grams. So what we want to do is figure out this, moles of water, and grams of water. All right. Okay, so you set the table up like I did in the last slide. You put the 5 here, and then you find out how many recipes. So you have 5 moles. Every recipe needs 1 mole per recipe. So you do the recipe, so you do 5 recipes. So 1 divided by 5 divided by 1 is 5. Okay, bring the 5 over here so you can do the recipe 5 times. So each recipe will give me 6 waters. So it'll be 6 5 times, 30. So you make 30 moles of water. Okay, now each mole of water weighs 18, and you have 30 of them, so it's going to be 18 30 times for 540. Okay. And there's your answer. So 5 moles of pentane will make 540 grams of water. Next problem says you have started out with 880 grams of oxygen. You want to know how many moles that is, how many recipes, how many moles, how many moles of pentane, and then how many grams. Okay, so we want to go over here. This is my final answer here. So first of all, you have to figure out how many moles 880 is. Grams, so each mole is 44. You have 880, so you can divide this up into groups of 44 to get 20 moles of carbon dioxide. Each recipe, you need 5. You have 20, so you can see that you can do 20 can be divided up groups of 5 4 times. So again, when you go up and dividing, so we can do the recipe 4 times with 880 grams of carbon dioxide. Okay, bring the 4 over here, so you can do the recipe 4 times. Every time you do it, you need 1 mole. So 1 4 times is 4 moles. So you need 4 moles of pentane. Okay, each mole is 72 grams per mole. And you have 4 of them, so 72 4 times is 288 grams. Okay, so if you need 880 grams of carbon dioxide, you have to have 288 grams of pentane. All right, next problem. So here's what you're starting out with. You want to get 720 grams of water, and what you want to do is you want to find out how many grams of oxygen you're going to need to make that. Okay, so first thing you have to do is figure out how many moles. So this is where you got to go. Question mark. So you have to figure out how many recipes. So every mole of water weighs 18 grams. So 720 can be divided into groups of 18 40 times. Okay, each recipe is 6. So you can divide 40 up into groups of 6.7 times, and we're rounding this to 6.7. Don't use repeating numbers like 6.666. Just round to the nearest tenth. All right, so I can do the reaction 6.7 times if I have 720 grams of water. All right, So I bring that over here, and then I find out how many moles of oxygen I need. Each recipe needs 8. I need to do it 6.7 times. So I'm going to do 8 6.7 times for 53.6 moles. Okay, each mole weighs 32 grams. I do that 53.6 times, and that'll give me 1715.2 grams of oxygen. So I need 1715.2 grams of oxygen to make 720 grams of water. Okay, study what we're doing here. Okay, so we started here and we want to end up here. Okay. Right, this problem, you're going to start out with 1024 grams of oxygen. And what I want to do is find out how many grams of everything else I'm going to have or need. Okay, so first of all, you need to find out how many recipes that this will make. So you have to figure out how many moles. So each recipe is, each mole is 32 grams. So I take 1024 and divide it up into groups of 32, and it ends up being 32. Okay. So the reason why both of these are 32, because this number divided by 32 gives me 32. So 1024 grams is the same thing as 32 grams of oxygen. All right, every time you do the recipe, you need 8. You have 32 of them, so you can divide the 32 into groups of 8 to get 4 recipes. Okay, all right, then bring the 4 across to everything, because you can do it 4 times. And then for pentane, you need 1 mole for every recipe. You have 4 of them, so you have 4 moles. Every mole weighs 72, so you're going to do 72 4 times for 288. Okay. Do the same thing for carbon dioxide. There's 5 moles per recipe. Do that 4 times. So you get 20 moles. Each mole is 44 grams per mole. So 44 20 times is 880. And then for water, again, you can do the recipe 4 times. Each time you do it is 6 moles. So do 6 moles 4 times for 24. And then you do 18 grams. Each mole is 18 grams. You do that 24 times, and you get 432. So you need 288 grams of pentane plus 1,024 grams of oxygen to produce 880 grams of carbon dioxide and 432 grams of water. Now, one thing to notice here is that the sum of these two equals the sum of these two, right? So the sum of the reactants equals the sum of the products. And that's because of the law of conservation of matter. It says you cannot create or destroy matter. So if you start out with 1,312 grams, you have to end up with 1,312 grams. Okay. So these types of problems, when you're just given one thing and you need to figure out, you will always have this situation here. And we'll see that there's this doesn't apply to every single type of this reaction, but it definitely does when you're only given one. In this case, you're given one thing. Okay, you're given oxygen, and you have to figure out other things. So if you go back and look at all the problems we've done, we've just been given one thing, either one, like I think first one we said we started with 4 moles. Okay, so when you only start out with given one thing, the product and the reactant masses will equal. Okay, and let's do another problem. The last problem is if you start with 360 grams of pentane, how many grams of water will you form? Okay, so I fill in my table. Okay, put the 360 here, divide it by 72, you get 5 moles, and divide it by 1 to get 5 recipes. Bring that over here. Every time I do the recipe, I make 6. I do that 5 times, so that's going to be 30 moles. And each mole weighs 18. So it's going to be 18 30 times for 540. Okay, now notice here is I just gave you one thing, and you therefore if you found the mass, this mass and this mass here, and added these two together and these two together, these two here would equal these two. Okay, and we won't do that, but it's a good check. That's a good check to do. All right, problem set number 3. And this one is going to be different than the previous one. This is where you're going to be given 2 reactants, not just one. Okay, in the previous problems you were only given one thing, either a product or a reactant. In these types of problems you'll be given 2 reactants, at least 2. Okay, more than one. Greater than or equal to 2 reactants. Okay. All right. So the way to do these, and I gave you a short video on how to do these. Okay, is you want to find out. So you're given 5 moles of pentane and 32 moles of oxygen, and what you want to do is find out which one of these 2 sets of moles, all right, gives the least amount of recipes. Okay, so what you do is find out how many recipes each one will do. So I'm going to take 5 and divide it by 1 to get 5 times. So each time I do the recipe, I only need 1. I have 5, so you can see I can do the reaction 5 times. Now, with the oxygen, I'm given 32 moles. Every time I do it, I need 8. So if I have 32 moles, I divide that by 8. I can do the reaction 4 times. Okay, now what you do is compare these 2 numbers. So this reaction, if you have 5 moles, you can do this reaction 5 times. And if you have 32 moles, you can do it 4 times. Well, hopefully you can see is that I will run out of my oxygen before I do the pentane, because I can only do it 4 times here. I can do it 5 times. So like I'll do it 1 time, and so I'll do it 4 times, and then when I get to the 5th time, I can't do it anymore because I don't have enough oxygen. There's enough pentane, but there's not enough oxygen. All right, so this is what we call our limiting reactant. So that's the first thing you do, is you compare the recipes. The lower recipe is called your limiting. And then what you do is you carry it over to your product side. Not to 5, just to 4. Okay, and then what you do is you figure out everything you need. So if you can do the reaction 4 times, you need 5 moles per recipe. You do it 4 times, you get 20. And then every mole is 44. You do that 20 times, you get 880. And for water, okay, you can do it 4 times as well. That's 6 moles per recipe. 4 times is 24. And then 18 grams, 24 times is 432. Okay. So the key is find recipes, compare recipes. The lower number is how much product you're going to make. All right. So the next problem is going to be a little bit more complicated. Right. So this time we're starting out 5 moles of pentane and 768 grams of oxygen. All right. Now, there are two different things, the moles and grams. Doesn't matter. You have to figure out how many recipes you can do with each one. Okay. So with 5 moles, you can do 5 recipes. And then for the oxygen, you have to figure out how many moles first and then figure out how many recipes. So 768 divided by 32 grams per mole gives me 24 moles. Then each recipe needs 8, so you can do divide 24 into groups of 8 to get 3 recipes. Okay. Now if you compare these two numbers, you can see that 3 is less than 5, so you can only do the reaction 3 times. So bring the 3 over here. Okay. Then you have then you figure out how many moles in grams. So every time you do it, you need 5 moles per recipe. Do that 3 times, or 15. And each one weighs 44. Do that 15 times for 660. And same thing over here. 3 times 6. And then, which is 18. You have 18 moles. Each 8 mole is 18 grams. So it will be 18 times for 324. Okay. And our limiting is oxygen. The pentane is what we call excess because you have more than you need. So we have your limiting and your excess. All right. Okay, the last problem here. So you're starting out with 180 grams of pentane and 512 grams of oxygen. Okay. First of all, you have to figure out how many recipes you can do for each. So you need to figure out recipes of pentane. So each mole is 72. So you divide 180 into groups of 72, you get 2.5 moles. Every recipe needs 1, so you can do it 2.5 times. All right. So the pentane says with the pentane you can do the reaction 2.5 times. Now how many times can you do it with 512 grams of oxygen? Well, divide that into groups of 32, you get 16 moles. Every recipe you need 8 moles. So you get 16 divided by 8 is 2. So you can do the reaction 2 times with 512 grams. Okay, so 2, you can only do the reaction 2 times because you'll run out of the oxygen before you run out of the pentane. So pentane is the excess, and oxygen is the limiting. Okay, now, in all the problems I've done, oxygen's been the limiting. It doesn't have to be. Okay. All right. Now bring the 2 over here and then figure out how many grams. Okay, so do it twice. Every time you do it, you need 5. So you do 5 2 times, 10 moles. Each mole is 44. So it'd be 44 10 times, or 440 grams. For water, each time you do the recipe, you need 6. You do that 2 times, so it's going to be 12 moles. Each mole is 18. So you do 18 12 times for 260. Okay, and there you go. All right, now one thing to notice about these problems is that if you add these two numbers here, it's 692. And if you add these two numbers, it's 656. Okay. When you have limiting reactions, the reactant does not equal the product in terms of grams. That's because you're going to have some of this left over. All right. Okay. Okay, so hopefully that helps. And I'll send out the test that'll be basically done on these. And you can use this for the test. Maybe, I think so, but make sure you study through it.